This is a hedging problem with the S&P 500 futures. And the goal in any hedging problem is to have an offsetting position in the futures market relative to your asset risk. And so you want equal dollar value, but you also want the dollar value adjusted by its volatility or risk. And so with stocks, usually we beta adjust the dollar values. So here's a problem. The fund has $800 million in it and a beta of 1.3. The fund manager wishes to reduce that beta by 0.3 down to 1.0. And to do that, we'll use the S&P 500 future. Now, since the S&P 500 is a leading market index and many contracts and positions and managers are evaluated against that index as our market proxy, it has a beta of 1. So 0.3 of that future size would reduce the beta from 1.3 down to 1. So the formula, very easy, just value of the asset divided by value of the future times beta of the asset divided by beta of the future in the case of 100% hedge. And in our case, we're just going to use a portion of that. And we'll present value this. We will tell the contract to reflect the fact that the future doesn't actually trade until sometime later on. And so we want the present value of that future contract price. So looking at this problem, if we were to solve it, value of the asset, well, 800 million, right? And the value of the future, well, the futures contract is 250 times the index price. And that was 2670. And risk-free rate, 1.6. And this future is only 1 month that we're hedging. Beta of the asset, 1.3. Beta of the future already, we know it's 1. And so we could easily calculate the full hedge. If we look at the full hedge, the number of contracts necessary, 1198. If we're only going to do a partial hedge, and that is reduce beta from 1.3 to 1.0, 0.3 reduction, then our beta adjustment is that we only need 0.3 of this position, the futures position. So the total position, almost 1,200 contracts, 30% of that is about 360 contracts. And so that's a S&P 500 futures hedge. Very simple formula, value and betas in the numerator for the asset, value and betas for the future in the denominator, just present value, whatever that ratio is. In the case of today's rates being low and only 1 month away, present valuing it doesn't really knock it down that much.